Welcome, sir. So, on behalf of NI Violet College, we are welcoming for the fifth session. So, yes, the session is yours, sir.
Thank you. Thank you very much. We are beginning with today's session, and today we will discuss about regression analysis. And I'll touch upon the correlation part also before we enter into the space of regression. Okay. So basically, I will first share a PowerPoint presentation, and then we will discuss everything with the help of the data. Okay. So just let me know when my screen is visible.
Yes, sir. It's visible.
Thank you. So before we understand regression, we talk about correlation. Correlation is basically the relation between two or more variables. Generally, we calculate a bivariate like relation of variable A, X, Y, Z. So X to Y, Y to Z, Z to X. Like this. In the bivariate form, we calculate all the relationships. Now, correlation is important. It is the foundation of regression. Okay, it is the foundation of factor analysis also. Like yesterday we discussed that the items are correlated with each other. The items which are highly correlated with each other makes a factor. Okay, no correlation, then no causal relationships. If there is no correlation, there is no regression also. We cannot say that X and Y are not correlated, but X affects Y. This is not possible. If they are correlated, then only there is an effect. The effect may be positive or negative, but the effect is only when they are correlated. This concept of correlation is useful to understand regression, exploratory factor analysis, and Cronbach's alpha. In fact, Cronbach's alpha is also based on the correlation. However, if the correlation is poor and number of items are high, still Cronbach alpha comes very high, but yes, it is based on the correlation only. Now, when we understand regression, it is linear regression. So we will cover only linear regression in our session. It is bivariate, but when one is bivariate regression. Bivariate regression means one independent variable, okay, and we have one independent variable and one dependent variable, okay. Only one independent and one dependent variable. Both should be on metric scale. Metric scale means either interval scale or ratio scale. Interval means that Likert type scale or like that. And otherwise it could be a ratio scale data. Ratio scale like exact money, age, income, number of hours of studies, marks in a subject, that is called ratio scale. Okay. So R standardized beta, then correlation. So all three will be same in case of bivariate regression. This is a simple intellect. We will see it later. Now, multiple regression is more than one IDV and only one dependent variable. So if I make a model here, so this is my DV, and this is IDV1, IDV2, IDV3, IDV4, and they affect the DV. So this is a kind of representation of multiple regression. Now they have the multicollinearity also. We'll discuss later after the examination of the results of regression analysis. Now, third type of analysis regression that comes is the multiple regression. Multiple regression with stepwise method. Earlier we were discussing with the enter method. You must have seen this enter method. Stepwise method is a very good method which removes the multicollinearity automatically. So more than one IDV and one DV, multiple regression, like a multiple regression. But what stepwise method does, it introduces the variables one by one. first variable which is most important. Okay, most important variable is entered first, and then slowly and steadily other variables are done. Okay, so this is the way that we go ahead. Now I'll take you to some data and we'll quickly calculate the correlation, regression, and multiple regression. So this is the data file. So we have MPG, engine, horsepower, and weight. First, let me introduce you with this data. The MPG is miles per gallon, like mileage of a vehicle, what mileage a vehicle gives. Engine displacement is basically the engine size. Horsepower is the power of the car, power of the engine, and weight is the total weight of the vehicle. Okay, so these are the four variables. We should be comfortable knowing the meaning of these variables. I can copy and make some file of notes. Okay, so we see what is the miles per gallon MPG, which means mileage of a vehicle. Right. Then we have, this is engine size, basically size of the engine. Then we have horsepower, power of vehicle, and then we have total weight of the vehicle. Total weight of the vehicle. All right. Now, if I ask you which is a dependent variable, which are independent variables, so we know that mileage is a dependent variable. If a vehicle is light, its power is less, it will take less fuel and the mileage will be high. A heavy vehicle will be having a low mileage, less mileage. So there is a negative relation of all three variables with the miles per gallon. There should be a negative relation. These are the independent variables. Okay. This is a dependent variable. So I can write IDV. This is IDV, and this is also my ID. All right. Now, first we will calculate correlation, and then we will calculate regression. So first we go to analyze by correlation by variate and put all the variables in this, click OK. Now let us copy this here and paste it here. Before I paste, I can reduce the table. I need only correlation value, not the significance or n. So I can double click on this, a tab pivot would come. This pivot is not there if I don't double click on the table. There is no pivot here. File, edit, view, data, transform, insert, format. If I double click, there is a pivot. So pivoting trays, statistics at the top, and variables on both sides. Cross it. This is my table of correlation. I copy it. This is Carl Pearson coefficient of correlation, which we have studied in graduation or even 12th, 11th or 12th, if we have studied the statistics. Just name. Sorry, due to some technicals, I had somebody because I'm in office. I got somebody for an urgent work. So I'm really sorry for the interruption. Okay, am I audible now? Am I audible? Am I audible?
Yes, sir.
Yes, sir.
Okay, fine. Thank you. So, so we were just discussing about the correlation. Now, see, correlation is, we consider correlation to be high when it is above 0.5. Okay, like you see, miles per gallon is correlated with all the three variables. We are not bothered about others because we are going to apply regression. So we forget this. Miles per gallon, which is a dependent variable, is correlated with all the three variables. That is engine displacement, horsepower, and vehicle weight. Okay, it is connected with all the three variables. These three variables are like negatively correlated. You see minus, minus, and minus. I told you earlier. Now the value of correlation varies from -1 to 1. -1 to 1. Now this -1 to 1 means that any variable, any correlation of two variables will either be -1 or less, or more, or 1 or less. So it is very close to -1, -7, -0.78, 0.76, 0.8. It means it is a high degree negative correlation. This has been shown that correlation is significant at 0.01 level of significance. This also shows that correlation is significant. So it's a high level of correlation. Now, we need to apply the regression analysis because correlation is high. Good, we can go ahead with regression. And let us see which of the three or all three variables affect the miles per gallon or not. Before that, let us see what is a bivariate and multivariate regression. Bivariate and multivariate regression. Now, bivariate is when we go for a bivariate one, I'm sorry, when we go for a bivariate one, we have two variables. Suppose I don't consider horsepower and vehicle weight, only engine displacement I consider. So I go to analyze, regression, linear. So here I click MPG, miles per gallon. Okay. Only engine displacement, nothing else. And click OK. All right. So let us go to coefficient only. So I get significant results, significant negative results, which means the null hypothesis is there is no impact of engine displacement on there is no impact of engine displacement on miles per gallon. No impact of engine displacement on miles per gallon. And find there is a significant impact on of engine displacement on miles per gallon. Now see, we can make a directional hypothesis here. Because we already know if the engine displacement is more, the miles per gallon will be less. Okay. So we make a hypothesis rather than making this non-directional hypothesis. We make that their engine displacement or a higher engine displacement decreases the miles per gallon. So this is a hypothesis showing a negative relationship, negative impact, or we can say higher engine displacement or engine displacement negatively affects the miles per gallon. Now, this is the way that I form a hypothesis, right? Now, what next we do is multiple regression. Okay, so that we'll see later. Now we see that there is a significant impact and which is a negative impact. So here the alternate hypothesis is accepted. Why? Because there is a significantly negative impact. Now, if we get a chance to go further, we can check all the three things bivariate in a bivariate way. So let us go. Now, with engine displacement is out, horsepower is in, okay, and this is the result. Coefficient is the result. Horsepower is okay. Paste. Now see, this is significant, isn't it? This is significant. Similarly, this is also negative beta and this is significant. Next we come to the horsepower is out, weight is, and we copy and paste, and now also it is significant but very less. I mean, the value is not very high. Beta is good, but standardized beta is not very high. Okay. Anyways, but all three are significant. So if we apply linear bivariate regression, all three results are significant. Okay. But what happens in multiple when all the IDVs are put together? Okay, let's see. So I'm applying multiple regression on this data. Linear regression. Multiple is not a rocket science. You put all the three variables together. Okay. MPG is here, vehicle weight, engine displacement, and horsepower. And click OK. Now, I will interpret it in detail. Model summary, ANOVA, and coefficient. All right. So in model summary, R square is important for us and adjusted R square. So I follow adjusted R square, which is more logical. Adjusted R square is 0.67, which shows 67% of the variation in the dependent variable is explained by the independent variables. All three independent variables explain 67%. What about rest 33? Rest 33% are explained by variables other than the variables taken in the equation. So in the model, we can say rather than equation, in the model. So we have only taken three variables which explain 67%, not the entire thing. All right. Now, how do we interpret ANOVA? How do we interpret ANOVA? ANOVA is a byproduct in multiple regression. Now, you see the significance. This shows that at least one of the independent variable significantly affects the dependent variable. So significance value shows it is below 0.05, hence that there is at least one variable which affects one independent, which affects the dependent variable. Okay, which affects the dependent variable. This is the interpretation. Now, when we go ahead to our final and most important table that shows IDV 1, 2, 3, all three IDVs. When we see the significance value, IDV 1 is significant, 2 is not significant, 3 is significant. So this is an interesting result for us. When we applied linear regression one by one, all three were significant. Now we can say that vehicle weight and horsepower significantly affects the miles per gallon. Okay, significantly affects the miles per gallon. All right. Vehicle weight and horsepower significantly affects the miles per gallon. Okay. Now see, what is the problem? Why engine displacement is not significant? When we individually checked it, it was significant. See, we checked this for the first. It is significant because significance value is below 0.05. But here it is not significant. This is a problem. So how to tackle this problem? This is not a problem actually. Thing is that there is an evidence of multicollinearity. Multicollinearity. So what is multicollinearity? Yesterday I defined it. Multicollinearity is the correlation between the independent variables. Independent variables. This is the multicollinearity. It is the multicollinearity is the correlation between the independent variables. Let's see whether there is a high correlation. So if there is high correlation, there is high multicollinearity. So we calculate the correlation, which is a bivariate correlation. Now miles per gallon is of no use for correlation because we are calculating the relation among the independent variables. So I click OK. Now you see that the independent variables, what is the maximum correlation? It is 1. And independent variables are correlated to 0.896, which is almost 0.9, 0.933, and 0.585. These are the repeated things because it is a cross correlation, so they will repeat the values. Now you see 0.896, 0.933, 0.858, which means the correlation value is very, very high, which means there is an evidence of multicollinearity. Because why there is called multicollinearity? Because one variable is doing the work of the other variable. That is why there is a multicollinearity. Like in a school, we don't require 2 math teachers, 2 Hindi teachers, 2 English teachers, 2 statistics teachers. We require one Hindi, one statistics, one mathematics. We require different teachers so that the different work is done, not the same work is done. So suppose a business analytics teacher can teach statistics. We don't require a statistics teacher. We only require business analytics teacher who can teach 2 subjects. Same is the case here. The work of engine displacement is done by, suppose, the vehicle weight. So when we enter one variable, so multicollinearity, if multicollinearity is there, we should remove multicollinearity, then apply regression. Okay. So how to remove? One is we can apply factor analysis. Okay. But for factor analysis, we should have many items. So in this case, not possible. Second, drop the variable. When we drop the variable based on VIF, VIF is variance inflation factor. So based on VIF, we can drop the variable, which is variance inflation factor. Okay. So drop the variable with highest VIF. We can do this. And second is apply stepwise multiple regression. Stepwise multiple regression. So both of the examples we will work now. Today we will engage the class till 3:55. Okay. So 10 minutes more we will engage, and then tomorrow we will extend to 2 hours around. Whatever ma'am will inform me, I'll do the accordingly. Okay. So we apply factor analysis, which is not possible. So we cut off this. Second, we drop the variable. But how to calculate VIF? So we can calculate VIF with the help of a formula also, and with the help of software also. So let us see how do we calculate in software. So first I go to this. In the regression analysis, there is an option of statistics. In statistics, there is an option of collinearity diagnostics. Collinearity diagnostics. We click on collinearity diagnostics, click on this, and then continue and OK. Now you see everything else is same. Just we have got two more columns in the coefficient table. Collinearity statistics, tolerance and VIF. So forget about tolerance, go to VIF. Maximum VIF is shown. One is 7.9, 10.5, 5. What is the threshold of VIF? Highest VIF, but not the variable below VIF of 5. So above 5 we need to drop. Above 5 is these two, vehicle weight and engine displacement. But even among between these two, engine displacement is the most dangerous one, which is having a VIF of 10 plus. Okay. So what we will do is we will simply remove this variable and apply the regression again. So we are removing engine displacement, clicking OK, applying again. Now the VIF is 3.7, 3.7. So now there is no problem of multicollinearity. And this is the final result. Okay. This is the final result. Okay. Now we can copy this result and paste it here. Copying this result and pasting it here. Clear? So this is the final result. We can even delete these two groups. All right. And these are significant as a final. Now, if it is final, we have dropped an item. Are we explaining the same, or we are explaining less, or we are explaining more? Interestingly, even after dropping a variable, we are explaining 67%. Earlier, we were explaining 0.670, and now we are explaining even more, 0.671. So the result is even better. After removing the multicollinearity, the results are better. Better results we are producing, so we should remove. Okay, now same thing we can do in stepwise multiple regression. The stepwise multiple regression, what we can do is we can simply go to linear regression. In stepwise, we can introduce all the variables. There is no issue. Okay. Enter method will be changed to stepwise. That is the only difference. Earlier it is enter, it is now stepwise. And we okay. Now in model summary, you can see the improvements. Now there will be two steps. There are two models. In first step, one variable was introduced, that is vehicle weight, explained around 65%. In second step, horsepower was also introduced. It affects 0.6.7, almost 67%. And this is the final model. Okay. In coefficients, we find two types of coefficients. One is, so we need not to see the collinearity diagnostic now. One is the first model and second is second model. Second model is important for us, where there are two variables. In first model, there is only one variable. Okay. But second, there are two variables which are significant. So in a coefficient, it will show only significant variables. It will not show insignificant variables because it is stepwise regression. Insignificant variable will be shown in the excluded variables list. This is excluded variable list. So excluded variables, it is showing the insignificant variable, which is in first, it has two variables, engine and horsepower, but later it introduced horsepower again. So only engine displacement is the variable that has been dropped. This is insignificant. Okay. So in my opinion, stepwise regression method is one of the best methods for applying multiple regression. Stepwise regression method should be applied while applying multiple regression to get rid of multi-collinearity issue. Okay. So this actually removes the multi-collinearity issue. We should have, and we should focus on what? R square wave, adjusted R square wave. Adjusted R square wave. All right. This should increase when we drop a variable. If this increases, then our model is better than the previous model. All right. So thank you so much for your patient and active listening. Hope I could clarify some of the points. So this is from my side. Thank you very much.
Hello, sir.
Hello. Yes, ma'am.
Sir, actually, I have a doubt, sir.
Please ask.
Sir, actually, what's my doubt means, sir, while I'm using this SPSS under the three methods, which one is more better, sir, while I'm going to take the data from the public, either ANOVA is good or correlation or the regression?
Ma'am, for all you are using eViews and SPSS. Which is the other software?
Sir, in SPSS, I'm asking the doubt, sir. If I'm
Uh-huh.
using the tool of ANOVA, correlation, and regression, which tool is
Uh-huh.
more effective while we are comparing all the three?
Okay. So see, it depends on your objective and nature of data you have collected. If your data is, say, you have DV and IDVs, right? Dependent and independent variables. So this is, say, IDV and DV. If your DV is metric, so IDV is non-metric. So you should go for what? ANOVA. Okay. If your both are metric, you can go for regression or correlation. Regression is better. Okay. Regression is better than correlation. That just depends on whether you want relation or impact. This shows the impact and this shows the correlation, relation. So impact is always better than relation, because when there is a relation, then only impact comes. But suppose if this is opposite, the dependent is metric and independent is non-metric. Okay. You should apply discriminant analysis. Okay. So there are different objectives. If you want to segment the masses, your respondents, you should apply cluster analysis. Every tool has a purpose. Okay. You can apply independent sample t-test tools. So if you are working on, say, demographics, then these tools are good. Generally, we work on demographics, then these tools are really very good. If we work on metric data, impact, effect, we work on regression. All right. So if you have any issues, maybe you can take my number from Radha ma'am, and you can contact me personally on WhatsApp. I will respond. Okay. That's all from my side.
Hey, sir. Yes, sir. So we didn't have
Yes.
any doubt, sir. So it is too useful session for us, and especially we are in SPSS. We have basic knowledge only. Now we have depth knowledge about this. So it is so useful and informative session, sir. So we will see in the next session.
Thank you. Thank you.
Sure. Thank you, sir.